Domain name service, or DNS. Some people understand what it is, they have an idea of how it works, but others don't quite realize how important it is in our day-to-day lives when we interact through the internet and with the internet. Effectively, DNS is the phone book of the internet. So it translates host names that we know into the IP addresses. So for example, if we know the host name www.google.com and we enter it in the browser, the underlying IP behind the Google's web server might be not different, but it's an IP basically. It's the address that computers understand. And what DNS does is it translates the domain name that we know into the IP address. For example, 12.13.14.15, right? Into the IP address that machines understand. It's a translator, a middleman between us and machines. Domain name service has evolved a lot over the last decades, I'd say. And before it became a server, something as we know, it used to be a local file, hosts file, which was nothing but a text file where administrators or users should have entered the lines for domain names. So for example, imagine that this is a text file, hosts, yeah? And it has Google, right, .com is 12, 13, 14, 15. So basically it was a phone book, local phone book of the computer. It was on Linux under etc hosts. Hosts was the name of the file, so it was under etc, and on Windows it was under drivers etc hosts. However, as time passed, it was impossible to continue using hosts file for several reasons. First, it became cumbersome, because there are so many websites we visit on a daily basis, right? When we search for something, when we do our online shopping, or we just surfing the internet. So it's impossible for us to sort of know all these IP addresses and put them into the hosts file and keep it updated, right? Second, IP addresses behind web servers change. If you already know how DHCP works, how IP addresses are allocated, you might have an idea that IP addresses are not the same. They tend not to be always the same for the web servers throughout the web server's lifetime. So maybe the underlying IP behind the google.com changed quite a few times over these past years. And you can't keep in touch with it, keep track of how it was changing in the hosts file. And another important reason why we can't use a hosts file, and we usually don't use hosts file nowadays, is the security. Hosts file is easy to be tampered with. So for example, you're using hosts file to locate the IP addresses of domain names, and then a middleman tampers your hosts file and puts another IP address for Google. So it's sort of, instead of 12, 13, 14, 15, it puts 15, 16, 17, 18. Which effectively leads you to another IP address and to another website, which can be sort of a malware, which can download something to your computer, and etc. So it's not safe. Hosts file is still used for testing nowadays, so you can sort of tamper it yourself if you want your kids not to go on Netflix but go on educational website. You can play a joke with them. You can change the netflix.com in the hosts file to another website, and each time they try to access Netflix, they will go to another website, right? DNS was a very effective solution to a domain name problem that people were facing back in the day. At the moment, DNS operates on port number 53. It is usually UDP, and many people know it as a UDP port. However, if domain name package is more than 512 bytes, it usually uses TCP instead of UDP. It's important to remember that. Before we delve further into DNS, it would be prudent to look at the structure. Let me come this way. At the structure of the domain names, of the websites or URLs as we're used to call them. So each domain name consists of several segments. And within the DNS topic, we will be looking at three key segments, parts of the URLs. So most URLs have subdomain, domain, and top-level domain. So we read URLs in the same way as Arabic language is read. We read them from right to left in the matter of importance. That's why we first look at the top level domain of the URL, which in this case, in the case of www.google.com, is com. In case of www.gov.uk, it's UK, the top level domain under which the domain is registered. The middle part, as you may see, the domain name itself is called domain or domain name. And that's basically when you register a domain name, that's what you try to register or privatize. And that's what people remember about your domain. And www, the part that comes before the domain, usually, is a subdomain. Subdomain is something that allows you to have different versions of your website and sort of have a better browsing experience for users. One of the examples of this is the maps.google.com. There is also translate.google.com that allows Google to create several subdomains for google.com domain, and it creates a better experience both for them because it's easier to sort of segment their different services, and for us, when we look at the URL and see maps.google.com, we automatically know what we're talking about. Top level domains can look differently, so they can differ from top level domain to top level domain. So for example, www.amazon.com. Amazon.com is usually in the US, right, under the .com TLD. But Amazon.co.uk is the British or United Kingdom version of Amazon. And that domain name is registered under .co.uk top level domain. So we discussed what DNS is and the parts of the URL. Now let's dive deeper into how actually the DNS service works. On a high level, when we open the browser and enter a URL to go to, browser is asking the DNS server, what is the IP of the www.example.com. So before taking you to the web server, browser needs to know what's the IP address, otherwise it can't bring you to the right web server. DNS server replies to your browser with the IP address of that browser, and using that IP address, browser reaches to web server. Under web server, I mean the URL that you're requesting. And URL replies to it with the content, with the web page that you see in front of yourself. This process happens in a very fast fashion, so you don't usually catch what happened and etc. And this is usually on a high level how DNS works. On a low level, DNS query includes 9 steps that you need to know about. Imagine that end user wants to access a website, right? And when he or she wants to access a website, it puts www.example.com into a web browser. Web browser contacts DNS Resolver. So this is an important part, please listen carefully. Web browser contacts DNS Resolver. DNS Resolver is nothing but a middleman, it's an agent. And DNS Resolver is checking then with several domain name servers what the IP address of www.example.com. First, it checks with root name servers. Root name servers is basically an index library. It's a library with books, and it's checking where it should look then for the top level domain of the website. So in example.com, the top level domain is com, right? So DNS Resolver asks root name server to let it know the IP address of the top level domain of com basically, and it returns to domain name resolver the IP address of top level domain name server. Please remember, it doesn't return the IP address that end user is looking for. It returns the IP address of the next server where DNS Resolver has to look. DNS Resolver, in turn, looks in TLD, top level domain name server. At top level domain name server, it's asking it. So there is a domain called example, right? And it's example.com. So I know that it's in your library, at TLD name server, right? Can you please let me know where I should look further for the IP address of this server? And top level name server says that it is in a certain authoritative name server, the name server where DNS Resolver should look for the IP of www.example.com. and it replies it with the IP of authoritative name server. Then DNS Resolver, as a seventh step, asks authoritative name server, do you know the IP address of www.example.com? And it returns to DNS Resolver the IP address of example.com, what we were looking for. DNS Resolver returns this IP address to the end user, and end user can now access the example.com. So on a more higher level, there are 4 DNS servers involved in the DNS queries. And these DNS servers are nothing but servers. Like, you know, service room, the hardware that we're using, you see, these are servers that are programmed to work as DNS servers. You might ask, why do we go through all these servers? Well, at the moment we have many different domains, and in order to manage them more effectively, they have been divided into different server types. Otherwise, it would be very hard, and these servers could go down because of DDoS or being overloaded. But the fact that they are sort of, the workload is divided between these servers, it's easier for them to handle all these DNS queries. So the first step, the first server is the DNS Resolver. We will look at it in more detail shortly. Then it's root name server. Right? What we're looking for at the root name server. We're looking for top level domain server's IP. Then we can go to top level domain server and ask, what is the authoritative name server where I can find example.com's IP? And it says, you know, authoritative name server's IP is this and this. Go and ask him. Then we go to authoritative name server and ask for the IP of this domain. And it returns the IP address. So what's the difference between these servers? DNS Resolver, as you see, it is just a middleman. It doesn't contain the IP address, or it doesn't contain the library of indexes with different servers. It only contains the information of root name servers that it will be querying. Root name server contains the information of TLD name servers, right, as a library. Imagine that each of them is basically a small library. And TLD name servers contains the IP addresses, the information of authoritative name servers, where we can further look for the IP that we're looking for. About the root name server and TLD, they never return IP. No IP of what we're looking for. It only returns the IP of the next server we should query, and that's it. They don't have the answer that we're looking for. They are only the servers that show us the right way. And then it's authoritative server that returns us the IP that we're looking for. And it's very important to understand that overall in the DNS querying, because it will help us to understand how the whole system works when we break it down in smaller steps. Now let's talk more about DNS Resolver. This guy over here. So DNS Resolver is performing several steps in order to find an answer for us. Imagine that you're in front of the computer and you put www.google.com. The first, what it does, it checks the local cache. Local cache of your computer is the information that is already stored on your computer. So for example, you have accessed google.com before and you have it in your browser's cache. It can be browser, it can be OS. Right? Along with that, it looks at the hosts file. So if we have the address for google.com in our hosts file locally on our laptop, the DNS query doesn't occur because we already found the IP. Or if the IP is found in the cache, we don't go ahead and do this query. Right? Because it's already in the cache. However, if the website's IP is not in the cache and it's not in the hosts folder, we then go ahead and identify the name servers, the root name servers, you see this guy over here, that we're going to query. Usually DNS resolvers have pre-prepared lists of root name servers and they usually query them, send echoes. So do you know what the IP address of .com TLD is? Do you know what the IP address of .com.tld is? Then when it receives the response, it analyzes the response. There are several responses that it can receive. It can be a success, meaning that it received the IP address of TLD name server that it can go ahead and query, which means that it's a success, so it continues the DNS querying, right? It can come across the error. So for example, certain root name servers, there are several of them, are down. And those that are down receive with the "we're down" message or the error. And what Resolver does, it removes these name servers, root name servers, from its list. It doesn't ask them again. So basically it sounds like, "Hello, do you know what the IP address of .com TLD is? Oh, sorry mate, today I'm down." And Resolver says, "Sorry, if you're down, I will not be asking you again. Bye." On a high level, that's what happens, and it removes this name server from its list of querying name servers and queries others. Obviously, if it's an error, it starts identifying the name server again. Or it can return a CNAME, which also reads as canonical name. We will review the DNS record types soon. However, you should know that canonical name in DNS record points us to another name, another domain. So basically, it never contains the IP and it never contains the answers that we're looking for. It just gives us another pointer and that's it to it. So for example, if we get the CNAME saying that google.com is actually boogle.com, you should look for boogle.com's IP, meaning that we start the process again. We again check our local cache, host file, we identify the root name servers to query, and we analyze the response. There is quite a lot of work that is done by DNS Resolver, and it's a very important part of the DNS queries. So it's sort of the project manager, basically, of the DNS querying, because it always put together the root name servers that it should query. It always knows what to do with the query types, and without it, the DNS wouldn't happen. However, essentially, these servers are, each server that we see are a bunch of different servers that are doing the DNS querying.